Welcome to the Great Geo Bake Off. This week is Metamorphism week and our contestants will have 50 million years to make the best metamorphic rock that they can. This week we would like our contestants to make us a metamorphic rock. Metamorphic comes from the Greek for change in form. So these rocks have gone through dramatic changes physically and chemically due to changes in heat and pressure. Our contestants can use any of the starting rocks that are here in front of them. We've got a sedimentary mudstone and we've got an igneous basalt. We would like our contestants to make their rocks in a convergent tectonic setting. So that is anywhere on Earth where tectonic plates are colliding towards each other. So that can either be a continental versus a continental plate collision or a continental versus oceanic plate collision. Our contestants have 50 million years in which to make their rocks, so get ready, set, bake! This is quite an interesting challenge for our contestants because they can make such a different range of rocks. They can vary temperature and pressure, and these will change depending on what different tectonic setting they put these starting rocks under, so I'm really excited to see what they come up with. Here is an example of the type of metamorphic rock that our contestants could make. This is a gneiss. This would have started out life as a sedimentary rock, kind of like this one here, full of muds and clays, and then it found itself in a continent versus continent collision zone where tectonic plates were colliding together, and it would have ended up in the core of a mountain. And here it would have experienced high temperatures and pressures, and that's what's caused this banded appearance that we see here. So how you've got these darker minerals separating out from the lighter minerals. We've also got the growth of some new minerals in here, such as these reddish pink garnets. One of the things that our contestants have to be careful of though is melting their rocks. So if you bake them to too high a temperature or too high a pressure, or if a little bit of water gets stuck in your starting rocks, then it's really easy to melt your rocks. Now that's fine, but when you've got a little bit of melt in your rock, you're kind of crossing the boundary between metamorphic and igneous rocks. And what we're asking for today is a melt-free metamorphic rock.
Welcome back to the Great Geo Bake Off. The time on the clock for the Metamorphic Challenge is 50 million years, so contestants, stop baking! Sadly, our host Stacy is no longer with us, so I will be taking you through the rocks that our contestants have managed to make and talking about the minerals that are inside them. So this is really fantastic. We have 3 very different metamorphic rocks that our contestants have baked for us today. So if we start with number 1 here, the first thing that's very striking about this rock is how much it glitters, and this is due to a mineral mica, and it's suggesting that it might be a schist, and we can actually tell that this is true because you can see some really nice layering in here. The other thing that you notice is that there are some red minerals too, and these are garnets. So we can tell that this is a schist that was probably metamorphosed in the middle of a mountain range during continental collision. The starting rock for this would have probably been a mudstone. A really beautiful bake, and really well done to that contestant number 1. If we now move over to rock number 2. Now this is quite different. There's really not much going on. And it's a shame really, because it's the very same starting rock that contestant number 1 started out with. Again, it was probably a mudstone, but the contestant here hasn't really cranked up the temperature very much, and probably lower pressures as well. So although it will still be a continental versus continent collision, they haven't put it very far down at all. Not a very sort of exciting bake, but actually since it's slate, probably quite useful. One of the things to note is that we can't really see any of the minerals in this rock with the naked eye, and we're going to need a microscope to actually look at them. So an interesting bake, but they could have probably tried a little bit harder with this one. So now we come over to contestant number 3. This rock is quite striking, and one of the main reasons is just the beautiful colours that it has. We've got the red garnets like we saw in contestant number 1's rock. This time they're much bigger, and we also have this really lovely green mineral here. This is a pyroxene. Now, pyroxenes form under a lot of different conditions, but the special thing about this one is that it's actually omphacite. Now, omphacite will only grow at very, very high pressures, and this indicates that this rock was put very deep beneath the surface, making it an eclogite. Now, eclogites can form under two main types of settings, either at the very base of a mountain range, alternatively it could have formed in a subduction zone. Now, subduction zone is where you have the collision of the oceanic plate with the continents, and the oceanic plate is forced beneath and down into the mantle. This rock here would have started out life as a basalt, so it's quite likely that it actually was from a subduction zone, because the oceanic crust is mostly made up of these types of rocks. One of the things that really impresses me about this bake is the technical ability that would have been required to make this rock. One of the risks of putting a rock in a subduction zone is that it doesn't actually come back. Most of the rocks that go down the subduction zone are recycled back into the mantle, and therefore you need to have a really special way of getting them back to the surface. This baker has skills. So now we come to the really hard part, which is where I have to select our star baker for this Metamorphic challenge. Now, we've got a real variety of rocks. They've used different starting compositions, they've used different pressures and temperatures, and we've ended up with a really great selection. I have to comment though on the slate. I feel like they could have tried a little harder, but if I need a new tile for my house, then good job. I think that in this case there is one rock that stands out for sheer presentation and the technical ability that must have been required in order to make it. This contestant took a real risk. So without further ado, I can reveal that our winner is contestant number 3, and the beautiful rock that we have here. This rock is an eclogite. It was quite high pressure competition this week, but next week we're cranking up the temperature. We're going molten. It's magma week.